Number 37, summation as n goes from 1 to infinity, 5 to the n minus 2 to the n over 7 to the n plus 3 to the n. So we can't use the exact same method of the direct comparison test. Let me fill that in over here. Actually, I cannot use the exact same direct comparison test as in number 36, okay? So what did we do in number 36? Whoops, sorry. Um, let's scroll up. I replaced this 4 with a 6 over here, yeah? So if we do something very similar and replace this 3 with a 7, this inequality sign will be greater than, okay? Since over here, once again, we're dividing by more. When we divide by more, the final value is going to be smaller, okay? And then I wrote as 2 times 7 to the n, okay? We do the exact same thing as number 36. We rewrite it like this. Both of these converge. So we know that this side of the inequality, imagine the summation sign there, will converge. But this guy's even bigger. Something bigger than something that converges could possibly diverge. That's what I'm saying over here. You need to understand this concept of how that direct comparison test works. You can't say that since something is bigger than something that converges, it's going to converge as well. That's logically doesn't work like that. Hopefully you understand that, all right? So we cannot use that. However, we can use the limit comparison test here. So if you watch number 36, I was saying the spirit of the limit comparison test and all that. So here I'm going to explain it, okay? So let me scroll up first and then I'll scroll to the text I wrote, all right? So here, as n keeps getting bigger, so as n approaches infinity, which term on top of this fraction will dominate? This 5 to the n will increase so much faster than this 2 to n, right? So this 2 to n is like nothing compared to 5 to the n, so we can ignore that. So 5 to the n remains on top, and similarly on the bottom, 7 to the n will dominate. 7 to the n will grow so much faster than 3 to the n will as n keeps getting bigger. So we keep 5 to the n and we keep 7 to the n. So 5 to the n divided by 7 to the n, that, let me scroll down now. We can write that as 5 over 7 to the n. This is a convergent geometric series if we place a summation sign there like this, yeah? Common ratio is less than 1, so it's a convergent geometric series. Okay, so this is exactly the spirit of the limit comparison test. Let's think about it. If you never learned this and you've just been following the procedure, I like my students to understand the concepts, okay, so that they remember the procedure much better most of the time. In this case, maybe not so, but I'll explain it if you're curious and interested. Okay, since as n keeps getting bigger, this guy will behave very similarly to 5 over 7 to n. Yeah, as I was saying, let's go back up. Sorry for all the scrolling. This term will dominate 5 to n, and 7 to n will dominate. These two are minuscule compared to those. So it does have some effect, but it's so small compared to how big these are. So let's go back down. As n keeps getting bigger, it's going to behave very similarly to 5 over 7 to n. Now imagine you divide our original guy by 5 over 7 to the n. Okay? Since they behave very similarly, the ratio of them is going to be some finite value that doesn't really change as n keeps getting bigger. Just imagine that. Let's say, okay? So let's say that n is 100. Okay, you're going to get some value here, and you're going to get some value for this 5 over 7 to n. N is 1,000. You're going to get some value here, and you're going to get some value here. If you divide the two, since as n is 1,000 and maybe even bigger, like 10,000, 100,000, these terms I was saying are getting more insignificant compared to these. Okay, it's going to, if you divide these two, it's going to be just some finite value. It's not going to be really changing. Okay, I should say some more precisely. It's going to be like a constant value, actually. And that's the spirit of the limit comparison test. Okay, hopefully you can think that through. Okay, I'll even try to throw this thought at you. If it's not a finite value, because remember the conclusion of the limit comparison has to be finite and positive. If it's not a finite value, it's changing, then the end behavior of the two is different. If it's a finite value, then the end behavior is pretty much the same. Maybe it just has a different scalar, like multiplication value, a scaled value, but it behaves very similarly. Yeah. That's the idea of the limit comparison test. So I don't think I explained it too well, to be honest, but I'll let you think about it and then you can flesh out the concept on your own. Okay. So if not, you never got explained that, hopefully that gives you a small picture of it. Okay. Okay, so now that I explained the concept, let's actually calculate the limit comparison test. So as I was saying, it's going to behave very similar to 5 over 7 to n. So let's just use that guy, okay? You have to be able to calculate this limit. It's not the most straightforward, but it's doable, okay? So limit as n goes to infinity of the original guy, divide by the one we want to compare with, dividing by 5 to n over 7 to n, same thing as multiplying by 7 to n over 5 to n, okay? Then you can use properties of exponents and all that to rewrite it like this over here, okay? And then I factor out a 35 to the n on the top and the bottom becomes like this. Again, careful with the properties of exponents, okay? These clearly cancel. So you're left with this over here. And as n goes to infinity, this guy will go to 0, so you're left with 1 on top. This guy will go to 0, you're left with 1 on bottom, so we're left with 1. So when you take the ratio of these, notice that since it's 1, the end behavior is pretty much the same. Or is the same, it's same. Because the ratio is what? Something divided by something equals 1. Those two somethings has to be the same. Yeah? Hopefully that solidifies the idea of the limit comparison test. Okay? So now let's finish the problem. Since this is finite and positive, and we know that 5 over 7 to the n converges, our original guy converges as well. So this is a bit longer than most of my videos in this series, but hopefully if you're curious about the idea of the limit comparison test and where it comes from, hopefully I kind of gave you the starting point to think it through and flesh it out on your own.